Hello, welcome to Tclassified. Today I'll be solving Waec 2017 chemistry theory. Question number 1A, Roman figure 1 says, what is an acid-base indicator? What is an acid-base indicator? Roman figure 2, give one examples of an acid-base indicator. Now, answer to the question 1A, Roman figure 1, we asked to give the meaning of acid-base indicator. Simply acid-base indicator. An acid-base indicator is either a weak organic acid or base which gives different colors in an acid or basic medium. Then we can still define it as an acid-base indicator is an organic dye which changes color according to the pH or hydrogen ion concentration of the solution. You just know that here we are just mixing or rearranging some words we use for the first definition. So organic dyes which changes color according to the pH or hydrogen ion concentration of the solution. Then we have to give the examples of an acid-base indicator. Just one example. Then we are having so many indicators. There are so many indicators we are using in titration. And in the indicators are: number 1, we have methyl orange as number 1. Number 2, we have methyl red. It's one of the indicator. We have phenolphthalein as one of the indicator. We have methyl yellow as one of the indicator. Then we have methyl violet. It's still one of the indicator we are using. Then we have litmus paper or solution. We have litmus paper or solution as one of the indicator. Then we still have bromo, thymol blue as one of the indicator used. So we can just pick any one out of the listed indicator. Acid-base indicator, as we are asked in 1A Roman figure 1, acid-base indicator is either a weak organic acid or base. It's either a weak organic acid or base which gives different colors, so it gives different colors in acidic or basic, in acidic or basic medium, or we can still say that an acid-base indicator, an acid-base indicator is organic dyes. So we can still refer to it as organic dyes. So organic dyes, so it is referred to as organic dyes which changes colors. So it changes colors so it is referred to as organic dyes which changes colors according to the pH. Changes color according to the pH, or hydrogen ions, or hydrogen ion concentration, hydrogen ions concentration of the solution. So it's referred to as organic dye which changes color according to the pH or hydrogen ion concentration of the solution. Then we are asked for the examples of an acid-base indicator in Roman figure 2. Then we have so many indicators. Number 1, we have methyl orange. methyl orange as one of the indicator. Then we still have methyl red. We have methyl red, so it's one of the indicator. We have phenolphthalein as one of the indicator. Phenolphthalein. We have litmus. We have litmus paper. Litmus paper or solution. Then another examples of indicator is methylfolate. Then another example is bromothymol blue. Bromothymol blue. So it's one of the examples of indicator. So we can just pick any one out of the listed indicator above. So because we are just asked to list only one, just give only one example of an acid base indicator. So anyone you choose out of these 6 is correct for the question asked. So if you like this video, click like and subscribe for more videos. Then you can still visit our website www.educateafricans.com for more videos on Waec 2017 chemistry theory past questions and solution. Thank you. God bless you. Welcome to Tclassified. Today I'll be solving question on Waec 2017 chemistry theory. Question 1b says state the properties exhibited by nitrogen 4 oxide in each of the following equations. We have to state the property exhibited by nitrogen 4 oxide in each of the following equation. The equation 1, we have copper, that is 4 mole of copper reacted with 2 mole of nitrogen 4 oxide, giving 4 mole of copper oxide and nitrogen gas. Then we have equation 2, we have water reacted with 2 mole of nitrogen 4 oxide, giving trioxonitrate 5 acid 1 mole. Then we still have 1 mole of HNO2. Then we have to state the properties exhibited by nitrogen 4 oxide in each of the following equations. That is, we can see that from the two equations given, we have nitrogen 4 oxide used to react with each of the other reactants. That is, we have nitrogen 4 oxide reacted with copper in the first equation. Then in the second equation we still have nitrogen 4 oxide reacted with water. Then we ask for the properties exhibited by nitrogen 4 oxide in each of these equations. Then for equation 1, nitrogen 4 oxide serves as oxidizing agent. So the property exhibited by nitrogen 4 oxide is it that nitrogen 4 oxide is an oxidizing agent. Then you can see that when we react nitrogen 4 oxide with copper, we have only copper for the other reactant, then we have it giving us copper oxide as the product. Then equation 2, we asked for the roles of nitrogen 4 oxide. The nitrogen 4 oxide also here is serve as an oxidizing agent. So it serves as oxidizing agent, and it also serves as reducing agent. So NO2 serves as an acid anhydride or mixed anhydride. So these are the properties exhibited by nitrogen 4 oxide in the second equation. So it also serves as oxidizing agent as well as reducing agent. Then we can still say that NO2 serves as an acid anhydride or mixed anhydride. So equation 1 for question 1b, so equation 1 for question 1b, equation 1. So the role of nitrogen 4 oxide in equation 1 is that it serves as oxidizing agents. So that is the role of nitrogen 4 oxide. Then we can see from the equation we have 4Cu, then we have it giving 4CuO. So we have this. So this nitrogen 4 oxide we have in here serve as oxidizing agent. Then Roman figure 2, nitrogen 4 oxide here also serve as oxidizing agent. It serves as oxidizing agent. So nitrogen 4 oxide serve as oxidizing agent as well as reducing agent, as well as reducing agents. So it serves as oxidizing agent as well as reducing agents. Then, or we can still say that NO2, that is nitrogen 4 oxide, serves as acid anhydride, serves as acid anhydride or mixed anhydride. So this is the role of nitrogen 4 oxide in each of the equation given. So in equation 1 it serves as oxidizing agent. As we denote it, we have just only formula of copper in the first equation giving copper oxide. So the roles the NO2 serve in that equation is that it serves as oxidizing agent. Then you can still see from the equation 2, nitrogen 4 oxide is also added to water, then giving HNO3 and HNO2. So nitrogen 4 oxide is also serve as oxidizing agent as well as reducing agent. Or you can see this as NO2 serve as acid anhydride or mixed anhydride. So this is just the answer to question 1B in Waec 2017 chemistry theory, that we have to state the properties exhibited by nitrogen 4 oxide in each of the following equation. So the answer is provided. For more solutions on Waec 2017 chemistry theory, click like button and subscribe. Then you can still visit our website www.educateamericans.com for more videos. Thank you. God bless you. Hello, welcome to Tclassified. Today I will be solving Waec 2017 chemistry theory. Question 1C, Roman figure 1 says define enthalpy of combustion. Define enthalpy of combustion. Roman figure 2 states why enthalpy of combustion is always negative. State why enthalpy of combustion is always negative. Now question 1C, Roman figure 1, we have to define enthalpy of combustion. Enthalpy on combustion is the amount of heat evolved, the amount of heat evolved or liberated. It is the amount of heat evolved or liberated when 1 mole of a substance is burnt completely in excess oxygen. So it is the amount of heat evolved or liberated when 1 mole of substance is burnt completely in excess oxygen. That is the definition of enthalpy of combustion. It is the amount of heat evolved or liberated when 1 mole of a substance is burnt completely in excess oxygen. Then Roman figure 2, we have to state why enthalpy of combustion is always negative. So enthalpy of combustion is always negative because heat is always given out. So enthalpy of combustion is always negative because heat is always given out, or the reaction is exothermic. Then don't forget that with the energy profile of exothermic reaction, we have it to be delta H is equals to negative. So enthalpy of combustion is always negative because it is always given out, or the reaction is exothermic. So we have to define enthalpy of question 1C, figure 1. We have to define enthalpy of combustion. So enthalpy of combustion, enthalpy of combustion is the amount of heat. It is the amount of heat evolved. It is the amount of heat evolved or liberated. It is the amount of heat evolved or liberated when we have 1 mole of a substance, when 1 mole of a substance is burned, when 1 mole of a substance is burned completely, in excess oxygen. When 1 mole of a substance is burned completely in excess oxygen, so it is the amount of heat evolved or liberated when 1 mole of a substance is burned completely in excess oxygen. So that is the enthalpy of combustion, that is the amount of heat liberated, or evolved when 1 mole of a substance, is burned completely in excess oxygen. So this is the answers to question 1C Roman figure 1. Then 1C Roman figure 2, we have to state why enthalpy of combustion is always negative. So enthalpy of combustion is always negative. Enthalpy of combustion is always negative because heat is always giving out, or the heat or the reaction is exothermic, Then don't forget that in exothermic reaction we have delta H to be equals to negative, that is heat is giving out. So that is why we have the enthalpy of combustion having its sign to be always negative, because of the heat that is given out. Then the reaction is also exothermic reaction. Then we have our delta H for exothermic reaction to be negative. So that is enthalpy of combustion. So we have answered question 1C Roman figure 1, that we have to define enthalpy of combustion. Then Roman figure 2, we have to state why enthalpy of combustion is always negative. For more videos, click like button and subscribe for more videos. Then you can still visit our website www.educateamericans.com for more videos on the past questions related to chemistry and solution. Thank you. God bless you. Hello, welcome to Tclassified. Today I'll be solving Waec 2017 chemistry theory. Question 1D Roman figure 1 says distinguish between a primary cell and a secondary cell. Distinguish between a primary cell and a secondary cell. Roman figure 2, give an example of each of the cells stated in 1D Roman figure 1. Give an examples of each of the cells stated in 1D Roman figure 1, that is primary and secondary cells. So we have to distinguish between primary and secondary cells. So let's use the tabular form to distinguish between the two, that is the primary and the secondary cells. So 1D Roman figure 1. So we have primary cell, then we have secondary cell. Then we say we have to use tabular form to distinguish between the two. So number 1, we have primary cell cannot be recharged. Primary cell cannot be recharged. It cannot be recharged. Why the secondary cell can be recharged? Secondary cell can be recharged. So that is number 1. We have number 2. Primary cell do not last long. Primary cell do not last long. Primary cell do not last long. While we have the secondary cell last long. Secondary cell last long. So this is number 2. Then number 3, we have reactions in primary cell are not reversible. Reactions in primary cell are not reversible. Reactions in primary cell are not reversible. Why the reaction in secondary cell are reversible? Reactions in secondary cell are reversible. Reactions in secondary cell are reversible. So this is the 3 given. That is, we have number 1, it cannot be recharged, while we have secondary cell can be recharged. And we have primary cell do not last long, while we have secondary cell last long. Then reactions in primary cell are not reversible, while reactions in secondary cells are reversible. So these are the 3 distinguishes between primary and the secondary cells. Then 1D Roman figure 2. 1D Roman figure 2. We have to give an example of each of the following. So that is, give an example of primary cell. Examples of primary cell. Then examples are the examples of primary cells. We have radio battery. So it's one of the examples of primary cell. We have dry cell. As one of the examples of primary cell. Then we have alkaline battery. So it's one of the examples of primary cell. Then we still have battery. We have button battery. So these are the examples of primary cell. Then secondary cell, we have to give the examples of secondary cell as well. Examples of secondary cell. Then the examples are, so we have the examples of primary cells to be lead acid. We have lead acid. So this is one of the examples of secondary cell. Then we have battery in rechargeable lamp. Battery in rechargeable lamp. So it's one of the examples of secondary cell. Then we still have car battery. We have car battery. Car battery is one of the examples of secondary cell. Then we have nickel metal hydride cell. We have nickel metal hydride cell. Then don't forget that we have to give only one examples of each of these cell, so you can just pick any one out of the examples. Like we have the primary cell examples to be the radio battery, we have dry cell, we have alkaline battery, then we have Bunsen battery, and so on. Then we have the secondary cell. The examples are lead acid, we have battery in rechargeable lamp, then we have car battery, we have nickel metal hydride cell. So these are the examples of primary and secondary cell asked. So we have asked or answer the differences between a primary cell and a secondary cell. Then in Roman figure 2 as well, we have answered the question asked, that is, we have to state the examples of the primary cell and the secondary cells. If you like this video, click like button and subscribe for more videos. You can still visit our website www.educateafricans.com for more videos related to Waec 2017 chemistry theory, past questions and the solution. Thank you. God bless you. Hello, welcome to Tclassified. Today I'll be solving Waec 2017 chemistry theory question 1E, which says define the term mole. Divide the term mole. Mole is defined as the amount of substance containing 6.02 times 10 raised to power 23 particles of that substance as present in 12 gram of carbon 12. Then don't forget that 6.02 times 10 raised to power 23 is what refers to as Avogadro's constant. So mole is defined as the amount of substance containing 2.02 times 10 raised to power 23 particles of that substance as present in 12 gram of carbon 12. Or you can still say that the amount of substance containing as many elementary entities as there are atoms in 12 gram of carbon 12 is referred to as mole. So mole is defined as the amount of substance, containing. Mole is defined as the amount of substance containing 6.02 times 10 raised to power 3, 6.02 times 10 raised to power 23. Then don't forget that this one is Avogadro's constant. So mole is defined as the amount of substance containing 6.02 times 10 raised to power 3 particles of that substance as present, particles of that substance as present in 12 gram of carbon 12, as present in 12 gram of carbon 12. Or you can still say that mole is defined as the amount containing of substance containing. Mole is defined as the amount of substance containing as many elementary entities, as there are atoms, as there are atoms, as there are atoms in 12 gram, there are atoms in 12 gram of carbon 12 gram of carbon 12. So this is just the answer to question 1E Roman 1E, that you have to define the term mole. So mole is defined as the amount of substance containing 6.02 times 10 raised power 23 particles of that substance as present in 12 gram of carbon 12. The mole is also defined as the amount of substance containing as many elementary entities as there are atoms in 12 gram of carbon 12. So this is just the answer to question 1E Waec 2017 chemistry theory. If you like this video, click like button and subscribe for more videos. You can still visit our website www.educateafricans.com for more videos related to Waec 2017 chemistry theory and other past questions. Thank you. God bless you. Hello, welcome to Tclassified. Today I will be solving Waec 2017 chemistry theory. Question 1F says calculate the amount of hydrochloric acid. Calculate the amount of hydrochloric acid in 40.0 centimeter cube of 0.40 mole per dm cube dilute HCl. Calculate the amount of hydrochloric acid in 4.0 centimeter cube of 0.40 mole per dm cube dilute HCl. Here we were just asked to calculate the amount. We were asked to calculate the amount. So we have amount of hydrochloric acid, amount of HCl, amount of HCl in 4.0 centimeter cube, 4.0 centimeter cube of 0.40 mole per dm cube of dilute HCl, of dilute HCl. Then here the number of mole, that is the amount is equals to CV, is equals to C, where we have our C to be the concentration in mole per dm cube. C is concentration in mole per dm cube, concentration in mole per dm cube. Then the value given in the question for our concentration in mole per dm cube is equals to 0.40 mole per dm cube. Then the V is equals to volume. V is equals to volume in dm cube, volume in dm cube. Then don't forget that from the question we are given volume as 4.0 centimeter cube. Then we have to convert it to dm cube by dividing by 1000, and we have it equals to, so when we divide it by 1000 is equals to 0.04 and we divide it by, that is the volume given from the question is 40 centimeter cube. Then we should know that this 40 centimeter cube should be converted to dm cube. Then we have 0.04 dm cube. That's our volume. Then our number, our n, that is the amount of HCl, is unknown. That is what we have to find here. So therefore the amount, that is N, is equals to, then our C, which is concentration, is equals to 0.40 mole per dm cube. Then we multiply it by the volume. Then the volume as calculated is 0.04 dm cube. Then the dm cube is, we cancel dm cube, then we are left with the mole. Then when we multiply 0.40 by 0.04, we are going to have our answer equals to 0.016 mole. 0.016 mole. So this is the answer to the question 1F that we have to calculate the amount of hydrochloric acid in 4.0 centimeter cube of 0.40 mole per dm cube dilute HCl, and the answer for the amount is 0.016 mole. If you like this video, click like button and subscribe for more videos. Then you can still visit our website www.educateafricans.com for more videos related to Waec 2017 chemistry theory and other Waec questions and solution. Thank you. God bless you. Hello, welcome to Tclassified. Today I will be solving Waec 2017 chemistry theory question 1G. Name two substances which can be used as electrodes during electrolysis of acidified water. Name two substances which can be used as electrodes during electrolysis of acidified water. The substances that can be used as electrode during electrolysis of acidified water are, we have number one, graphite. Graphite is one of them. Then don't forget that this graphite is one of the allotropes of carbon. So graphite is one of the allotropes of carbon. So it's one of the electrode using during the electrolysis of acidified water. Also we still have number two to be platinum. Platinum is one of the electrodes used during the electrolysis of acidified water. So we have two electrodes used that is the substance used, or that is the substance as asked from the question, that is the substance used as electrodes during electrolysis of acidified water. In acidified water are so we have number one to be graphite. Number one is graphite. Then don't forget that this graphite, as discussed above, is one of the allotropes of carbon. So graphite is one of the allotropes of carbon. Then number two substance used is platinum. So platinum is one of the two substances used as the electrode in electrolysis of acidified water. So we have answered question 1G, that we are asked to name two substances which can be used as electrodes during electrolysis of acidified water. Then we state the electrode as the graphite, which is one of the allotropes of carbon, and number two, which is platinum. So these are the answers. If you like this video, click like button and subscribe for more videos. Then you can still visit our website www.educateafricans.com for more videos on Waec 2017 chemistry theory solutions and other videos related to chemistry solutions to Waec questions. Thank you. God bless you. Hello, welcome to Tclassified. Today I will be solving Waec 2017 chemistry theory. Question 1 each. List two forces of attraction that can exist between covalent molecules. Then Roman figure 1, we have to name the product formed when butane undergoes incomplete combustion. The question again. Question 1H. List two forces of attraction that can exist between covalent molecules. Then Roman figure 1, name the product formed when butane undergoes incomplete combustion. Then the two forces of attraction that can exist between covalent molecules are: number 1, we have van der Waals forces or induced dipole forces. We have van der Waals forces or induced dipole forces. That's number 1. Number 2, we have hydrogen bonds. We have hydrogen bond. So it's one of the bonds that can exist between covalent molecules. Then number 3, we have permanent dipole interaction or dipolar forces. So these are the three forces of attraction that can exist between covalent molecules. Then question 1 figure 1, we have to name the product formed when butane undergoes incomplete combustion. The product formed when butane undergoes incomplete combustion. The products formed when butane undergoes incomplete combustion are carbon 2 oxide. When butane undergoes incomplete combustion, the products formed are carbon 2 oxide and water. Carbon 2 oxide and water. So we have question 1H. So we are asked for the two factors of attraction that exist between covalent molecules. The number 1, we have hydrogen bonds. So it's one of the forces that exists between covalent molecules. Then number 2, we have van der Waals forces. So it's one of the forces that exist between covalent molecules. Van der Waals forces, or we call it induced dipole forces. Induced dipole forces. So this is one of the forces that exist between covalent molecules. Then number 3, we still have permanent. We have permanent dipole interaction. Permanent dipole interaction, or we call it dipolar forces. Then don't forget that we are just asked to list only two, so we can choose out of the listed 3 forces that exist between covalent molecules. Which one of them is hydrogen bonds? We have van der Waals forces, which is induced dipole force. Then we have number 3, permanent dipole interaction or dipolar forces. So we can just pick any 2 out of them. So then in figure 1, we have to name the product formed when butane undergoes incomplete combustion. Then the products formed when butane undergoes incomplete combustion. are, we have carbon 2 oxide, carbon 2 oxide, carbon 2 oxide. Then another product formed when butane undergoing complete combustion is water. We have water. So these are the two products formed when butane undergoes incomplete combustion. So we are just answer question 1H and Roman figure 1 of Waec 2017 chemistry theory. For more videos, click the like button and subscribe. Then you can still visit our website www.educateafricans.com for more videos related to Waec 2017 chemistry theory and other videos on the past questions and solutions. Thank you. God bless you. Hello, welcome to Tclassified. Today I'll be solving Waec 2017 chemistry theory question 1J. Write the electronic configuration of ion 3 plus with atomic number 26. Write the electronic configuration of ion 3 plus with atomic number 26. Then we should know that here the ion 3 plus we are having here shows that this ion has lost part of its electrons, that is, that lose 3 electrons, which means the electron number will remain 23. So we have the ion with atomic number 26, but the equation is as we have ion minus 3 electron, then we are going to have the product to be ion 3 plus. So that is, we have this ion has lost 3 electrons. Then ion in its elemental form having atomic number 26 protons and 26 electrons. So this is ion in its elemental form. But when we have ions, that is ion 3 plus, so we have 26 as the atomic number. Then here we are going to have 26 protons plus 23 electrons, because it has lost part of its electron number having 3 plus. Then we have ion 3 plus with atomic number 26. Then the electronic configuration is going to be 1s2, 2s2, 2p6, 3s2, 3p6, and we have 3d5, because we have ion 3 plus and it has lost 3 electrons. Then having 3d here shows that ion is one of the transition elements, that is the d block element. So this is also the electronic configuration of ion 3 plus, showing that it has lost 3 electrons. For more videos, click the like button and subscribe. And you can still visit our website www.educateafricans.com for more videos on Waec 2017 chemistry theory and solutions. Thank you. God bless you. Hello, welcome to Tclassified. Today I will be answering Waec 2017 chemistry theory question 2A, Roman figure 1. Hi, state the periodic law. I state the periodic law. Then 2, we have what is meant by the term periodic properties of elements. What is meant by the term periodic properties of elements. Then for Roman figure 1. The periodic law states that the properties of the elements are a periodic function of their atomic numbers. Periodic law states that the properties of the elements are a periodic function of their atomic numbers. Then we have Roman figure 2. What does it mean by the term periodic properties of elements? Periodic properties of elements is any physical or chemical properties of an element which changes regularly with increasing atomic number. Periodic properties of elements is any physical or chemical properties of an element which changes regularly with increasing atomic number. For example, we have ionization energy. So ionization energy increases across the period as an example. So for 2a Roman figure 1 high, then we have to state periodic law. We have to state periodic law. So high, periodic law states that the properties of elements are the periodic function of their atomic number. So periodic law states that the properties of the elements are the periodic function of their atomic numbers. Then in figure 2, we are asked what is it meant by the term periodic properties of elements. So periodic property of elements is any physical or chemical property of elements, any physical or chemical property of an element which changes regularly with increasing atomic number, So periodic property of elements is any physical or chemical property of an element which changes regularly with increasing atomic number. And we give one example here as ionization energy, and these properties increases across the period as the atomic number increases, So we will just answer question 2a Roman figure 1I, which asks us to state the periodic law and what does it mean by the term periodic properties, and the two have been answered. If you like this video, click like for more videos related to Waec 2017 chemistry theory and solutions. Then subscribe for more videos. You can still visit our website www.educateafricans.com for more videos. Thank you. God bless you. welcome to Tclassified. Today I'll be solving Waec 2017 chemistry theory. Question 2a, Roman figure 2. List the properties of an element which shows periodicity. We have to list the properties of an element which shows periodicity. Then the properties of an element which shows periodicity are melting and boiling point. We have number 2, electronegativity. Number 3, we have atomic or ionic radius. And we have electrical and thermal conductivities. We have metallic and non-metallic properties. Another one is ionization energy. Then you can still have electropositivity. So these are the properties of an element which shows periodicity. Like we have number 1 of the properties which shows periodicity. Number 1, we have melting and boiling points. Melting and boiling points as first one. So it's one of the properties of an element which shows periodicity. Number 2, we have electronegativity or electropositivity. Then the next one, we have ionization energy. We have ionization energy. So ionization energy is one of the properties of periodic table that shows periodicity. So it's not only that, as we have been listing them, we have melting and boiling points, we have electronegativity, then we have ionization energy. Then number 4, we have metallic and non-metallic property. Metallic and non-metallic property. So it's one of the properties that shows periodicity. Then number 5, we have electrical and thermal conductivity. Electrical and thermal conductivities. So it's one of the properties that shows periodicity. The next one, we still have atomic or ionic radius. Atomic or ionic radius. So it's one of the properties that shows periodic table. Then don't forget that we have to list only 3 properties of an element which shows periodicity, but we have provided 6 options now, so we can just pick any one of the 6 options provided. So any one of them picked is correct for the question asked to list 3 properties of an element which shows periodicity. If you like this video, click like button and subscribe for more videos. Then you can still visit our website www.educateafricans.com for more videos on Waec 2017 chemistry theory and solutions or other chemistry past questions. Thank you. God bless you. Hello, welcome to Tclassified. Today I'll be solving Waec 2017 chemistry theory. Question 2a, Roman figure 3. Explain briefly how each of the properties listed in 2a Roman figure 2 varies across the period. Explain briefly how each of the properties listed in 2a Roman figure 2 varies across the period. Then the properties listed in 2a Roman figure 2 are electronegativity, we have ionization energy, we have electron affinity, we have metallic and non-metallic properties, then we have electrical and thermal conductivity as one of the properties that shows periodicity listed in 2a Roman figure 2. Then here we were just asked to explain briefly how each of these properties listed in 2A Roman figure 2 varies across the period. Then for the properties are the electronegativity, ionization energy, then we still have melting and boiling points, melting or boiling points. We have electrical and thermal conductivity, electrical and thermal conductivities. We still have atomic and ionic radius. So we were just asked to explain briefly how these properties listed varies across the period. And don't forget that we were just asked to explain briefly only 3 out of them. Then number 1, let us choose melting and boiling points. Then how it is varies across the period. So it increases, that is, melting and boiling point increases due to increase in strength, due to increase in strength of the metallic bond, while melting and boiling point for non-metallic, melting and boiling points of non-metallic elements, decreases due to decrease in van der Waals forces of attraction. Decrease in van der Waals forces of attraction. So this is just for the melting and boiling points. Then number 2, let's choose ionization energy as one of the property which shows periodicity across the period. Then we look at ionization energy increases due to the increase in proton number. Ionization energy increases due to increase in proton number. So ionization energy increases due to increase in proton number, or increase nuclear charge, or increase in nuclear charge, or decreased atomic radius, or decreased atomic radius. So that is the trend in the variation of ionization energy across the period. So let us choose this electron affinity, electron affinity, electron affinity, electron affinity as one of the properties which shows periodicity across the period. Increases, electron affinity increases due to electron affinity increases due to decrease of atomic number, due to decrease of atomic radius, due to decrease of atomic radius. Electron affinity increases due to decrease of atomic radius or increase in nuclear charge, or increase in nuclear charge. So electron affinity increases due to decrease of atomic radius or increase in nuclear charge. So for the sake of the question asked, we just asked to briefly explain how each of the properties listed in 2a Roman figure 2 varies across the period, and we listed 3 properties which shows the periodicity across the period. We listed only just 3, and that's why we explained only 3 here. Then the properties are electronegativity, ionization energy, melting and boiling points. Here we have electrical and thermal conductivities, then we have atomic and ionic radius. So if you like this video, click like and subscribe for more videos. You can still visit our website www.educateafrican.com for more videos. Thank you. God bless you. Hello, welcome to Tclassified. Today I'll be solving Waec 2017 chemistry theory question 2b. Says define relative atomic mass. Question 2b says define relative atomic mass. And relative atomic mass is defined as the number of times the average mass. The relative atomic mass is defined as the number of times the average mass of one atom of an element is heavier than 1/12 the mass of the one atom of carbon 12. Relative atomic mass is defined as the number of times the average mass of one atom of an element is heavier than the 1/12 the mass of the one atom of carbon 12. And we can still define relative atomic mass as the ratio of the average mass. Can also be defined as the ratio of the average mass of one atom of an element to 1/12 the mass of an atom of carbon 12. So we can still define it as the ratio of the average mass of one atom of an element to 1/12 of the mass of an atom of carbon 12. Then we can still have the relative atomic mass defined this way as the average mass of one atom of an element on a scale in which one atom of carbon 12 weight 12 AMU. The average mass of one atom of an element on a scale in which one atom of carbon 12 weighs 12 AMU. So we define the relative atomic mass as that. Then don't forget that the symbol is AR. So we have the relative atomic mass. So we have to define relative atomic mass. Relative atomic mass. Relative atomic mass. That is AR. Relative atomic mass. Then is defined as the number of times. Relative atomic mass is defined as the relative atomic mass is defined as the number of times. Defined as the number of times the average mass. The average mass of one atom average mass of one atom, average mass of one atom of an element, one atom of an element is heavier than 1/12, heavier than 1/12, heavier than 1/12 the mass, heavier than 1/12 the mass of one atom, of one atom of one atom of carbon 12, one atom of carbon 12. So you can still define the relative atomic mass, the relative atomic mass, relative atomic mass. You can still define it as the ratio of the average, we define as the ratio of the average mass. We define as the ratio of the average mass of one atom, of an element, to 1/12, the mass, 1/12 the mass of an atom, of carbon 12. So it can be defined as the ratio of the average mass of one atom of an element to 1/12 the mass of an atom of carbon 12. Also, we can still have relative atomic mass. Relative atomic mass can also be defined as the average. So relative atomic mass is the average mass of one atom, average mass of an atom, average mass of an atom of an element, an atom of an element on a scale, in which one atom of carbon 12, in which one atom of carbon 12, in which one atom of carbon 12 weighs 12 mU. So you can still have a relative atomic mass defined as the average mass of an atom of an element on a scale in which one atom of carbon 12 weighs 12 mU. So this is just the answer to the question that we asked to define the relative atomic mass. So we define the relative atomic by giving three definitions of relative atomic mass. So that is just the answer to question 2B of Waec 2017 chemistry theory. If you like this video, click the like button and subscribe for more videos. You can still visit our website www.educateafricans.com for more videos on Waec 2017 chemistry theory questions or other chemistry theory questions and solution. Thank you. God bless you. Hello, welcome to Tclassified. Today I'll be solving Waec 2017 chemistry theory question 3C. Sulfur 4 oxide is converted to tetrasulfur 6 acid according to the following equation. 2SO2, that's sulfur 6, 2 mole of sulfur 6 gas reacted with oxygen in liquid state, also reacted with 2 mole of water in liquid state, giving 2 mole of hydrogen tetraoxosulfate 6 acid in aqueous form. If 1.5 moles of oxygen reacts with sulfur 4 oxide, calculate the mass of tetraoxosulfate 6 acid produced. And we were just asked to calculate the mass of tetraoxosulfate 6 acid produced. Then don't forget that the formula for calculating mass is that we are going to have number of mole is equals to mass over molar mass. Then by making the mass as the subject of the formula, we are going to have the number of mole times molar mass. So we have, let's say, solution. We are asked to calculate the mass of tetraoxosulfate 6 acid, that is H2SO4, produced. Then we should know that number of moles is equals to mass over molar mass. Then to calculate mass, the mass is made as a subject of formula. Then we are going to have mass is equals to number of moles multiplied by molar mass. Then with this we need number of mole. Before we can calculate the mass. Number of mole then is unknown here. Then we need molar mass also, is also not here, molar mass. Then we calculate the molar mass of H2SO4. Molar mass of H2SO4 is equals to, we have 2 moles of hydrogen, 2 atoms of hydrogen, that is 1 multiplied by 2, plus 1 mole of oxygen, that is, there is 1 atom of oxygen present in hydrogen tetraoxosulfate 6 acid. So we have 1 mole of sulfur present, so we are going to have it reacted with 32, plus then we have 4 atoms of oxygen present in tetraoxosulfate 6 acid, that is 4 multiplied by 16, then this gives, we are going to have 2 plus 32 plus 48 plus, okay, we have 4 multiplied by 16, we are going to have 64, so it equals to 98 gram per mole. It's equals to 98 gram per mole. That is the molar mass of hydrogen tetraoxosulfate 6 acid. Then we still want to calculate the number of mole. So then from the question we are having 1 mole. From the question we have 1 mole of oxygen gas. 1 mole of oxygen gas gives 2 moles of H2SO4. Give 2 moles of H2SO4. From the equation we are having 1 mole of oxygen here gives 2 mole of hydrogen tetraoxosulfate 6 acid. So we are going to have 1.5 moles of oxygen gas gives 1.5 multiplied by 2 moles multiplied by 2, that is moles of hydrogen sulfate H2SO4. Then the answer is 3 moles. So we are going to have 3 moles here. 3 moles. That is 1.5 mole of oxygen gas will give 3 moles of hydrogen tetraoxosulfate 6 acid. So our number of mole here is also 3 mole. Then from the formula above we are having mass. Mass is equals to number of moles multiplied by molar mass. Then we have calculated the number of moles to be 3. Then we have also calculated the molar mass to be 98 gram per mole. Then we are going to have everything to be in gram. So we have 98 gram per mole, so is equals to, when we multiply 3 by 8, when we multiply 3 by 8, we are going to have 294 gram. That is, don't forget that the unit is in gram. Then we come about this by having 3 moles multiplied by 98 gram per mole. Then mole will cancel mole, leaving only gram. So it means our answer is 294 gram. So that is the mass of hydrogen tetraoxide of a 6 acid produced. We have just answered Waec 2017 chemistry theory. For more videos, click like and subscribe. You can still visit our website www.educateafricans.com for more videos related to Waec 2017 chemistry theory and other Waec chemistry theory and solutions. Thank you. God bless you. Hello, welcome to Tclassified. Today I'll be solving Waec 2017 chemistry theory question 2C Roman figure 1. What phenomenon is exhibited by an element given as symbol like Z, which exists as having mass number as 35, then atomic number is 17, then another atom of the same element having atomic number 17, then mass number 37. Then Roman figure 2. What accounts for the differences in the mass number of the elements? What accounts for the differences in the mass number of the element? Then Roman figure 3. Calculate the relative atomic mass of these elements if the percentage abundance of one of the atom of element having mass number 37, then atomic number 17 is 75%. Now to the Roman figure 1, we are asked for the phenomenon exhibited by an element given as symbol like Z, which exists as the mass number 35, then another one having mass number to be 37, then each of them having 17 as their atomic number. Then the phenomenon exhibited by this element is what refers to as isotopy. The phenomenon is isotopy because isotopy is the phenomenon whereby atom of the same element having the same atomic number but different mass number, and we can see that in this symbol given. So they have the same atomic number but different mass number. So the phenomenon exhibited by this element is what refers to as isotopy. Then for Roman figure 2, what accounts for the difference in the mass number of the elements? Then what accounts for the difference in the mass number of this element is that we have difference in the number of neutrons. The number of neutrons of each of these elements is different. So difference in the number of neutrons accounts for the difference in mass number. Then Roman figure 3, we have to calculate the relative mass of this element with the percentage abundance of one of the atom of the element given as 75%. Then the mass number of this element is 37, while the atomic number is 17. So the phenomenon exhibited by the atom of this element is what refers to as isotopy. So question 2C, Roman figure 1. So the answer is isotopy. Then should not forget that isotopy is the phenomenon whereby atom of the same element having the same atomic number but different mass number. So 2C Roman figure 2. We were asked for what accounts for the difference in the mass number of the elements. What accounts for the difference in the mass number of the elements? Difference in the mass number. in the mass number, difference in the mass number is due to the difference in neutron number. So as we can see, for the first element having atomic number to be 35, the mass number is 17. So neutron number is equals to mass number minus proton number, then which is equals to the mass number here is 35 minus proton number, which is 17. So the neutron number is 18. Then we have the another atom of the same elements with mass number 17, mass number 37, then atomic number 17. So neutron number for this one is equals to mass number minus proton number, then the mass number here is 37 minus proton number, which is 17, is equals to 20. So we have difference in their neutron number. So this difference in their neutron number accounts for them having different mass number, because mass number is equals to sum of the proton number and the neutron number. Then question 2C, Roman figure 3, we have to calculate the relative atomic mass. The relative atomic mass is equals, so we are given one atom of this element to be 37 as mass number, then 17 as the atomic number. Then they say the abundance is 75%. Then for atom having 35 as the mass number, then 17 as the atomic number, then abundance is equals to 100 minus 75, then is equals to 25%. So the abundance in nature of this atom is 25%. Then relative atomic mass is equals to, we are going to have 75% of one atom, which is 37, then atomic number is 17, plus another atom having 25% abundance of 35 of the mass number, then is equals to, we have 75 over 100 multiplied by 37, then plus 25 over 100 multiplied by 35. So the answer for this, so the answer for the two, when calculated, we are going to have 25% of, we have 75%. So don't forget that we have 75% of 37 as the mass number. So the elements here having 75% abundance in nature, then the mass number here is 37. So when we calculate it, we are going to have 0.75 times 37, 0.75 times 37, then the answer here is 27.75. Then for this one, we are going to have 25 divided by 100 25 divided by 100, then we are going to have is 0.25 multiplied by 35. So we multiply 0.25 by 35, giving it multiplied by 35 here. So is 0.25. We say we have to multiply it by 35, then our answer is 8.75. 8.75. As for what we have in the question, when we add 27.75 we add it to 8.75, so our answer is equals to 36.5. Going for the question given. So if you like this video, click like and subscribe for more videos. Thank you. God bless you. You can still visit our website www.educateafricans.com for more videos. Thank you. Hello, welcome to Tclassified. Today I will be solving Waec 2017 chemistry theory. Question 2D Roman figure 1 says, state the method used for collecting each of the following gases. State the method used for collecting each of the following gases. In Roman figure 1, we have carbon dioxide gas, that is CO2. Then we have hydrochloric gas. We have hydrogen chloride gas as the number 2. Then we have Roman figure 3, we have hydrogen gas, H2, as the third gas. Then 2D Roman figure 2, we have to give a reason for our answer in 2D Roman figure 1 and 2. So we have to give the reasons for our answers. So we have 2D Roman figure 1, then the high we have there, that is how are we collecting carbon dioxide gas, the method used for collecting carbon dioxide gas. So the method used for collecting carbon dioxide gas is by downward delivery or upward displacement of air. So it's by downward delivery or upward displacement of air. Then for the hydrogen chloride gas also, it is also collected by downward delivery or upward displacement of air. While we have the hydrogen gas as well, it is also collected by upward delivery or downward displacement of air. So that is how we collected the three gases, as in 2D Roman figure 1. Carbon dioxide gas is collected by downward delivery or upward displacement of air. Also we have the same thing for hydrogen chloride gas, that is also collected by downward delivery or upward displacement of air. Then we still have hydrogen gas collected by upward delivery or downward displacement of air. Then 2D Roman figure 2, we have to give the reasons for our answer in 2D Roman figure 1 and 2, that is the reason for having carbon dioxide and hydrogen chloride collected by downward delivery or upward displacement of air. Then the reason is that carbon dioxide is heavier or denser than air. Carbon dioxide is heavier or denser than air. Then hydrogen chloride gas also is heavier or denser than air. That is the reasons we have to give for having our carbon dioxide and hydrogen chloride gas collected by downward delivery or upward displacement of air. Then 2D Roman figure 1.
He was made the prime minister.
2D Roman figure 1.
You need to be intelligent, you need to be able to do things.
So we are asked for the method used for collecting carbon dioxide. So carbon dioxide is collected. Carbon dioxide is collected. So it's collected by downward delivery. So carbon dioxide is collected by downward delivery or upward displacement. Upward displacement of air. Upward displacement of here. Then we have hydrogen chloride gas as well. Hydrogen chloride gas, HCl. Then it is also collected. By downward delivery. It's also collected by downward delivery. Downward delivery or upward displacement or upward displacement. Upward displacement. Upward displacement of air. Upward displacement of here. Then we have the last of the gas. We have hydrogen gas. So hydrogen gas is also collected. By downward delivery. It's also collected by downward delivery. Also collected by downward delivery or upward displacement. Upward displacement of here. Then we have 2D Roman figure 2. 2D Roman figure 2. We have to give the reasons why carbon 4 oxide is collected by downward delivery or upward displacement. And the reason is carbon 4 oxide is heavier. Carbon 4 oxide is heavier. Carbon 4 oxide is heavier or denser than air. Or denser than here. So that is how it is collected by using that method stated in 2D Roman figure 1. Then we have Roman figure 2 as well. We have Roman figure 2, which is HCl. HCl. Why is it collected? Using downward delivery or upward displacement of here. It is also that hydrogen chloride gas is heavier or denser than here. So we are just answer question 2D Roman figure 1, 2D Roman figure 2 of chemistry 2017 chemistry theory. So if you like this video, click like and subscribe for more videos. And you can still visit our website www.educateafrican.com for more videos. Thank you. God bless you. Hello, welcome to Tclassified. Today I'll be solving Waec 2017 chemistry theory question 3C. Sulfur 4 oxide is converted to tetrasulfate 6 acid according to the following equation. 2SO2, that's sulfur 6, 2 mole of sulfur 6 gas reacted with oxygen in liquid state, also reacted with 2 mole of water in liquid state, giving 2 mole of hydrogen tetraoxosulfate 6 acid in aqueous form. If 1.5 moles of oxygen reacts with sulfur 4 oxide, calculate the mass of tetraoxosulfate 6 acid produced. And we were just asked to calculate the mass of tetraoxosulfate 6 acid produced. Then don't forget that the formula for calculating mass is that we are going to have number of mole is equal to mass over molar mass. Then by making the mass as the subject of the formula, we are going to have the number of mole times molar mass. So we have, let's say, solution. We are asked to calculate the mass of tetraoxosulfate 6 acid, that is H2SO4, produced. Then we should know that number of moles is equals to mass over molar mass. Then to calculate mass, the mass is made as a subject of formula. Then we are going to have mass is equals to number of moles multiplied by molar mass. Then with this we need number of mole. We need number of mole before we can calculate the mass. Number of mole then is unknown here. Then we need molar mass also. Is also not here. Molar mass. Then we calculate the molar mass of H2SO4. Molar mass of H2SO4 is equals to, we have 2 moles of hydrogen, 2 atoms of hydrogen, that is 1 multiplied by 2, plus 1 mole of oxygen, that is, there is 1 atom of oxygen present in hydrogen tetraoxosulfate 6 acid. So we have 1 mole of sulfur present, so we are going to have it reacted with 32, plus then we have 4 atoms of oxygen present in tetraoxosulfate 6 acid, that is 4 multiplied by 16, 4 multiplied by 16. Then this gives, we are going to have 2 plus 32 plus 48 plus, okay, we have 4 multiplied by 16, we are going to have 64, so it equals to 98 gram per mole. It equals to 98 gram per mole. That is the molar mass of hydrogen tetraoxosulfate 6 acid. Then we still want to calculate the number of mole. So number, then from the question we are having 1 mole. From the question we have 1 mole of oxygen gas. 1 mole of oxygen gas gives 2 moles of H2SO4. Give 2 moles of H2SO4. From the equation we are having 1 mole of oxygen here gives 2 mole of hydrogen tetraoxosulfate 6 acid. So we are going to have 1.5 moles of oxygen gas gives 1.5 multiplied by 2 moles multiplied by 2, that is moles of hydrogen sulfate H2SO4. Then the answer is 3 moles. So we are going to have 3 moles here. 3 moles. That is 1.5 mole of oxygen gas will give 3 moles of hydrogen tetraoxosulfate 6 acid. So our number of mole here is also 3 mole. Then from the formula above we have mass. Mass is equals to number of moles multiplied by molar mass. Then we have calculated the number of moles to be 3. Then we have also calculated the molar mass to be 98 gram per mole. Then we are going to have everything to be in gram. So we have 98 gram per mole. So is equals to, when we multiply 3 by 8, when we multiply 3 by 8, we are going to have 294 gram. That is, don't forget that the unit is in gram. Then we come about this by having 3 moles multiplied by 98 gram per mole. Then mole we cancel mole, leaving only gram. So it means our answer is 294 gram. So that is the mass of hydrogen tetraoxosulfate 6 acid produced. We have just answered Waec 2017 chemistry theory. For more videos, click like and subscribe. You can still visit our website www.educateafricans.com for more videos related to Waec 2017 chemistry theory and other Waec chemistry theory and solutions. Thank you. God bless you.